Okay, we are going to continue on this here. So let me just make sure everything is good to go. And it looks like we just went live right now. Alright, so we're going to continue. Let me make sure I have all my settings right here. Looks like we do. Looks like we're good. OBS open. Public. Yep, looks public. No viewers. That's okay. Alright, so I'm just going to continue here writing these repair.wiki articles. And we left off right here, so check CD3217 support voltages. I don't know quite how I want to do this yet. I don't know if I want to do... I'm just going to do S2 rail missing, I believe, instead of... I ate something unhealthy that I probably should not have eaten, Thomas. Okay, so we're going to group this into S2 rails missing. So if any of the S2 rails above RC missing, proceed to yeah, YouTube is just being weird, Thomas. Let's see, can we group this into, actually, 79, I'll look at page 79 in the schematic. Is this even the right board? No, what is this board? Oh, this is the board I was working on. Alright, we're going to move to a different one. (2016) and here is our correct schematic now. And we're going to go down to page 79. What is going on today? Alright, so let's have a look at these rails here. So 3v3 S2 5v G3S. Okay, this is interesting. Okay, so they're counting G3S as S2. So 5v S2, these are all sourced off of this. So 5v S2 charger main, that's VDD main, 3v8 ALN, 1v8 S2 VDD1. I know this can cause, this right here, 1v8 S2 causes different issues. So we're going to group this into, yeah, so see 3v3 S2 is different. Sourced by, from PPBus, enabled by question. Not even the Apple engineers know. Anyway, UPC is probably going to come on our second page of power aliases, because they usually do. Any lines that come from our PMICs usually going to come on this page. Okay, so we have Cetra and Symmetra, which are PMICs, and we have our 1V52 or 1V25S2 power rail, and that's Symmetra Buck 13. And I think someone just walked in my store. I don't know. I'm going to go check real quick. Or at least check the camera. Nope, nobody's there. Okay, so these come from our PMIC. I'm looking for 3V8. 1V8S2 comes from our PMIC. 1V06 S2. And Sarah LDO7, which is what we're looking for. Okay, so how am I going to word this? I think what I'm going to do is consider this, let's do, if any, let me proceed to CD3217 support S2. I don't like this. Support S2 rails low or missing below. There we go. So let's mark that. Alright, that's marked, so that's our next step. Now we have to come up with a criteria to test the CD3217. And most times when the CD3217s are bad, well, I shouldn't say most times. I'm actually going to write, so if everything that we just wrote is present and working, then the chances of a CD3217 issue are pretty high. It's pretty high up on the list. Another possibility is a firmware issue. So we're just going to mark, we're just going to put down, okay, we're going to go into bold now. 3, if all above findings negative for any issue, one or both of the CD3217s may be failed or may have a surrounding circuit issues such as a blown trace, broken trace, or blown resistor. Firmware issue is also possible, but unlikely if the device is not in DFU or recovery mode. Also should note that this, a very rare cause would be a dead SoC, but I've never seen that yet, so we're going to leave that out for now, but that can theoretically cause this. Okay. And then we are going to do CD3217 diagnostic process. May have failed. Thank you, Rob. 1, 2, 3. 1, 2, 3. CD3217. Okay. There is no definitive diagnostic test to confirm a CD3217 is the cause of the issue, or cause of an issue. No, that doesn't sound right. There is no definitive diagnostic test to confirm that a CD3217 is the cause of an issue a board is experiencing. Other than replacing it, however, you can, how am I going to word this? I don't know. However, some findings can suggest a fault with one or both of the CD3217s, period. Okay, so let's talk about determining if CD3217s are the issue. Now, CD3217s have many functions. They have LDO lines. They have a MOSFET that passes charger voltage in. And one of the most common things that we see when, let's say, a board is not turning on, or if there's a CD3217 issue, is one CD3217 will not be passing PPBus through. Now remember, both these have to communicate with each other, and if one is bad, then it's not going to work. Okay, so we're just going to do test one, measure, let's do this in italics. PPDCN, AON, CHGR. ON underscored CHGR. Catherine is here. Peter is here. Warren is here. Underscore R on measure test one, measure PPDCN underscore A1 charger R on both ports to determine if the internal MOSFET in one CD3217 is not opening, and determine if one MOSFET, determine if the internal MOSFET in one CD3215 is not allowing charger voltage through to if PPDCN underscore AON CHGR it's present on one port but not the other. The CD327 of the issue. Oops. Shoot. Okay. So I want to clarify one thing here. You can determine which CD32 teen measuring voltage on the input fuse that correlates with the chip. And we're just going to make a note here. So we have FF201, which correlates with UF500. To FF201, or was it 0201? Yeah, 201, which correlates with UF500. FF200 is going to correlate with UF400. Alright, people in chat, is this hard to understand here? Okay, so if you have the USB-C port plugged into one port, it's going to go to one CD3217. If you have it plugged into the other, it's going to go to the other one. You figure that out, which one is in use, by measuring voltage on the fuse. Okay, so there's that. Test 2. What the? I don't want this. Test 2, test 1. And we're going to look at the LDOs on this. So 3v3 UPC LDO. Let's do some checking real quick. Okay, back to OBS, so I'm going to do some checking. Alright, so here's the board we're working on. Oh, wow, okay. It's a donor board. This is what happens. But anyway, I want to see which voltages I have. So an LDO is a low dropout voltage from the chip. It's basically, just think of it as like a little voltage that comes out of the chip that can power some things. No need to overcomplicate things. I need a good USB-C port. Those things vanish in plain sight, I swear. Good USB-C ports just vanish on my desk anywhere. No matter where they are, they just manage to vanish. Got one here, though. All right, plug this in. And my meter is dead. Let me change the battery in my meter real fast. And the other battery is also dead. So let me go grab, I don't feel like going to walk to the front to get batteries, so I'm just going to grab meter off Caleb's desk, which will work just fine for this. Point 3. All right, so those are both present no matter what port is being used. Okay, perfect. Batteries are fine. I just stole the fuse out of your meter. That would be even worse. Measure the LDO outputs. Both CD32 17s. Determine if one of the ICs isn't outputting proper voltage. Where does 1v5 core go to? And I'm curious, I just need to double check if this actually goes to, yeah, okay. It's an internal LDO, it's an internal, oh, I didn't switch it, did I? No. Wrong one again. I honestly, I cannot wait for 2 days off. I'm tired. I've worked hard to get this thermal paste out. I hope people actually buy it. And one of the concerns, I'm not gonna lie, I do have with this thermal paste is someone is gonna use this on a device that it's not meant for, and they're gonna complain that it's thermal throttling. You ultimately can't make people read. I put on the website in several places that this is intended for only the devices that use this black thermal compound. I even put a compatibility chart, but I know someone's going to do it and they're going to call up and say, your thermal compound sucks, and I'm going to have to tell them, no, you're just being dumb because this is a very specific product. It's kind of like engine oil, right? Let's say your car takes, let's say 5W30, and then you go and buy 10W40 and put it in your engine. Okay, that's not the right way to do things. Or let's say your engine requires 10W40 and you go and put 0W20 in it, and then you're complaining, you call up Valvoline or Mobil or someone and complain that my engine is ticking because I put the wrong oil in it. Okay, that's just like thermal compound. Devices have heatsink clearances, and thermal compounds are not a one-size-fits-all solution there. But anyway, I am ready for a couple days off for sure. And we're going to go back to display capture. Okay, so this LDO, this is a line internally that the chip creates to power another portion of itself. Okay. Same with this right here. Okay, this does some other things as well. This powers the ROM, it looks like. Very, very important. Go back to chat. Oh, yeah, so here's another thing. With this thermal compound, okay, due to some of the particle sizes, now I should say this is not harmful whatsoever. It's not harmful, but in one of the particular materials, particularly the material that makes the compound turn black, the particle sizes of that are very, 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 very small. And this stuff will find its way into the tiniest pores of your skin. So just take that into consideration, that it is kind of hard to clean off of your skin. I don't really see that being a problem though, because I don't care. I mean, it's not harmful. It's literally, there's nothing in this paste that's harmful to a human being. The only somewhat harmful compound in there is zinc oxide, which is on the SDS, which is harmful to fish, and it's also the same thing in sunscreens. So it's not really a concern. I mean, I wouldn't go eating thermal paste by no means, but it's not harmful to get on your skin or anything. It's just hard to clean off. Okay. To measure the, okay. Determine if one of the ICs isn't outputting proper voltage to its LDO lines. The LDO lines from the CD3217's power internal portions of the chip, as well as power the TBT ROM, which is needed for proper function of both CD. Okay, so what are our two LDOs? We have PP3v3 underscore UPC0 underscore LDO, PP3v3 underscore UPC0 underscore LDO, outputted from, is outputted proper? That doesn't sound right. UF400, UF400 and powers the TBT ROM. And TBT ROM is UF260. 260, period. UPC0 LDO, PP1v5, UPC0 LDO underscore core, PP1v5 underscore UPC0 underscore LDO underscore core. Yeah, if the voltage is low on one of the LDOs, it will affect both CD3217s. Because if the voltage is low, that means something internally is wrong with the CD3217, and they need to communicate for each other. So for whatever reason the communication is bad because one of the chips is bad, then it's not going to work. LDO core from UF400 and powers internal CD functions. Normal voltage. Supply is a better word. You're absolutely right. Uh, 1.5 volts. Again, I always mark them about because you'll have somebody you'll have somebody that'll see like 1.495 and be like, oh, it's low, I need to change this chip. No. Slight values should be ignored like that. In most circuits, I should say. Our next one on the list. UPC1. Okay, so same thing, just UPC1. V3 underscore UPC1 underscore LDO. UF 500, and what do you power? Internal chip functions. And powers internals. 3217 functions. Normal voltage equals 3 volts. 5. So when did you say it's too low? 1.3 volts? I would say anything less than like 3.1 volts would be too low. Like 3.293, 3.25, you know, 3.2, whatever, that's fine. 3.1, below 3.1, I think there would be a problem there. Okay. If you let any LEO voltages are low, replace the CD. No, I don't want to say that. If any of the LDO voltages are low, check for a short to ground on the correlating line. No short ground is found. So yeah, I would say like plus minus 0.1 volt would be normal. Like this board I just measured was like 1.45, which is fine. Anything below 1.4 I would consider abnormal. Let's do resistance here too. I wanted, because LDO lines typically fail in a way that they're like low, like partial shorts. So normal diode load. I'm not going to have a separate section from this. I'm just going to put it right here. So normal mode ground reading equals let's do diode mode, red probe on ground, and we're doing 3v3. .493. 0.493. .512. Alright, so we're just going to do around 510. Around 510. And we'll just call the other one just around 500. So both around the same. So 0.510. Alright, that's good. Alright, so that's clear. That's how you diagnose CD3217 issues. You may not find any findings, and you'll have to empirically replace them. But there's that. Okay. So we're going to reuse some of this from our other page here because there's no sense in just repeating myself for PPBus and DFU with, of course, added steps. Let me go ahead and pull this up. We're just going to modify this. Is the closest to the display page. Let's make sure all this format's right. Looks pretty good. One mistake I have to fix. Alright, next one, which is going to be PPBus. Caleb, chat speculated that you were taking home USB-C ports from here and selling them. Okay, so let's... What do we have written for... do we not have it written down here? We got to. Here we go. Let's lower absent window, short to ground. Okay, so... This one's gonna need some work. PPBus underscore AON shorted to ground. And the next one, PPBus AON absent or low with no short. I try and like to put effort into this, to make sure it's confusing, not as confusing as possible, as least confusing as possible. Low, shorted, low, or shorted to ground. Okay. This does not apply anymore. What's a good spot to inject for in this board? We're going to use our same point right here. C5960. C5960 is a good place to voltage 2 on the 820-0-2016 logic board. Caleb is here. Caleb needs a lemon thrown at him when he comes back to work. That's done. PPBus, AON, absent or low with no short. Now this one can be more rare than a short for sure, but still common. And this is honestly, these next two pages we're going to be writing are going to be the most in-depth. So. Okay, so we're just going to, we're going to paste what we did before and we are going to change this. So PPBus AON. Harshad, how's it going? U5200. The USB-C voltage is 5 volt. ISL 9240 will boost the 5 volt input to 12 volts. If the USB-C voltage is 20 volts, the ISL 9240 will buck lower to 20 volts. We'll lower the 20 volt input to 12 volts. That's right. PP DC in underscore AON underscore CHGR underscore R is making it to the ISL 9240. U5200 U5200, and a good place to measure this from is going to be C5202, 520, pretty much C5201 to 5204. To a 1 or 201 5202. That's fine. This is a shunt resistor. One of these failing would be pretty rare. However, it must be noted that if you have 0 volt, if you do I really need to repeat this? If you get 0 volts on PPDC chart, you check. However, it must be noted if you have 0 volts here, one of the CD 217s is probably bad. Of steps. Hey Jim, what's going on? Hope all is well. I can't wait to go home. Holy crap, I've been streaming for an hour. It has not felt like an hour. So R50, 21, and 22. I like when Apple keeps stuff the same. $52.61 and $52.62. Alright, that's done. Let's take a look at formatting. I'm gonna save it just in case. What's funny is I did worked on the 82179 page for almost 2 hours, And this laptop decided that it was going to go on fire when that happened. Well, not on fire, but the DC in jack just burned for some unknown reason. And it shut off, and I lost my work. Luckily, Lenovo has decent warranty, and it was fixed. I actually replaced the DC in jack, but the board was kind of burned. But they did not care that I worked on my laptop prior. Okay, so this looks good. Everything here is decent. Okay. Now we're going to discuss 3v8 AON. So 3v8 AON is going to be outputted by U5700, which is right here. Let's have a look at the schematic and see what enables this. So I have current sensing. I have not seen many issues with this other than my mom is in chat. Why do you say that about Stella? Stella's fine. Stella's at home. Alright, so we have an enable here. We obviously need the enable. 3v8 AON power EN. I haven't seen too many issues with this missing, so I can't really talk about how this fails because I just haven't seen it. But I at least want to go over checking the enable. So we need to check VIN, we need to check enable. And where is this enabled from? It's from, looks like a switch charger. Ah, okay, I see what you're doing here. I see how they've have this designed. The enable is from U5200. Got it. So that's the first thing we need to check. Why does it say I'm not logged in? Log in. I like how my pug has become world famous in this chat. People all around the world know about my pug. Don't forget about my MacBook. That's Caleb. Tag Caleb E in chat because that's something he was supposed to fix yesterday, and hopefully he did. Is Caleb still here? Here. Okay. Caleb is in trouble. Caleb is in danger of losing his employment. He's probably not even in chat anymore. Short to ground on P3V. I don't mind repeating stuff when I'm writing this stuff because people tend to forget even if what they're doing is right above them, so it doesn't hurt to. Is it 82 or am I way off? No. See 5889. See 5887. 87. Say good place to measure from. Normal diode ground equals around. Let's measure and let's find out. Caleb really doesn't get fired, he just gets citrus thrown at his head. Alright, normal diode mode to ground is going to be 0.350. 350. Step 2. Check the signal to 57. P3V8 AON power EN. Wait, am I getting that right? P3. Underscore EN. Let's do a side note. P3V or EN is applied by the ISL 9240. U5200 and this is, what is this guy right here? This is, I don't want to put something down to confuse somebody, so I'm just going to put delay switch, okay? Is, okay, we need sourced from charger EN underscore MVR from ISL 92200. and passes through a delay switch U5340. Through a delay switch U5340, where it outputted, no, supplied, as 3V8. If a short to ground is identified, find, replace the shorted component. For more information on how to find short circuits, please see this page. I don't think, I've never seen a delay switch like this go bad on one of these machines yet, but it's, you know, it's plausible that the delay switch can go bad, so I'm just going to list it. So, I mean, we're basically creating a diagnostic criteria. V8 power missing voltage on. We're just gonna put R5340. R5340. VR. If charger is missing, replace U5200. Yeah, that's good. Charger EN MVR is present, but P3 3V EN is missing. Potential faults could include U5340. I mean, there's not much else that can do this. U53, check messenger, okay. That's very good, Caleb. I'm glad that you have a good place to sleep on the roof of your other employer's building. That sounds very comfortable, to say the least. That sounds very comfortable indeed. Could include 340 or surrounding traces / resistors. There's that. So that's checking enable on 3V8 power EN. So that's step 1. Check for short to ground. Check the enable. So short enable, we need VIN as well. So we're just gonna write that. Step 3, ensure that the VIN PPBus AON making it to U5700. Occasionally a via or trace can break, resulting in a voltage not making it to a few to some parts of the board. Definitely, Jim, definitely give your cardiologist a call if you haven't. That's definitely something that should be investigated and treated. I want to see something real quick. Amazing. Okay, so 19% CPU usage. This is an i9 something something. What is this? i9 10885H. 19% usage. With the M1, this would be pegged at like 90% or so. CPU usage, and GPU, I don't know, 70% GPU usage. It's sitting around 68. That's totally cool. I wonder what my CPU's been sitting at this whole time. Because I've been streaming on this all a long time. And this poor thing renders 4K video. I play games on it. It lives a hard life. It's an absolute workhorse. And as I expected, our CPU is toasty. Which is kind of expected. I mean, that's normal for it to get hot like this. If this i9 does get hot, it does run here. That's fine. We're at 37 watts, so that's why. Hey John, how's it going? So we just need to check on C5704 and C58. I have very bad short-term memory. Like, I don't remember what I just looked at, so C5704 and C5804. '87 at load is totally normal for an Intel mobile CPU. Could see that it wasn't actually at 87. It was sitting at 100 something at 19%. That's totally normal for Intel CPUs. That's just how they behave. They run hot, they turbo boost up, and this is, let's see what our highest frequency reached was, okay? Because that's really what matters. What frequency is it hitting when it gets to these temperatures? Core temperature. So this actually, our actual CPU temperature is 100. I look at package more than cores. And our max has been 4.8 gigahertz, 4.5 gigahertz. So that's about, you know, normal. This can go up to 5.3 on one core, I think. But yeah, this is all normal for the CPU. It's at 104. That's totally normal for short term. That's not going to harm anything. You can see that this will actually, our PL1 power limit's 45 watts. I think I can actually, yeah, that's why. This makes it, that'll be better for this. Okay, I just changed the power setting to turn it down a bunch, and that's going to go down to 35 watt for PL1 power limit. A PL2 power limit, meaning for boost, is on the CPU is up to 135 watts, which is more than most desktops. And this is a ThinkPad. Still an amazing laptop. But okay, and then if all above findings negative for issues, replace U5700, period. Done. Bold. Let's do this bold. No, this is a laptop. 135 watt CPU and a laptop. It's a ThinkPad T15G, if anyone's wondering. Let's read this back. That's not right. We did a screw up in here. Alright, this looks pretty good. I mean, that's quite a lot of info in here. Bryce, I think Caleb is planning on working for you. He keeps talking about moving to Santa Clarita. So for all I know, you're trying to bribe him more money to work for you instead of me. Alright, so we're going to do this in 3 sections for each rail. Now 2 of them are going to be kind of lousy. Usually, I'm really tired. I want to go home, but I can't go home yet. Almost. Usually when your S2 rails are missing, it's a short to ground somewhere. That's what I've seen. We just had a board, a 820-2020 with a short on one V8 S2. There was a short to ground, presented a little bit differently. I've seen other boards, 5 volt 0.03, that was a short to ground on 5VS2 near the Wi-Fi. So it's usually short to ground, but circuit issues, you know, are not impossible, obviously. So let's go ahead and note this. I think he requires payments in Skittles, Bryce, because he was picking up Skittles off the floor here yesterday. Okay. In most cases, low or missing voltage on S2 rails will be due to a short to ground or an enable issue. Period. We just noted that because it could be enable. Peanut M&Ms are good. Those are the best. Alright, we're at PP5VS2. PP5VS2. This one really has the most potential to short, at least in my opinion. S2. Alright, I'm going to give my eyes a break. I just need to not focus on the screen for a few seconds. Okay. Produced from UC300. What does this use? Yeah. Okay. Where does this come from? What kind of, oh, yuck. Alright, so this is enabled from the PMIC from U8100. Yeah, and the thing with PMICs, whenever there's a PMIC enablement thing, it could be because the PMIC is bad, it could be because the CPU isn't talking to this, it could be a clock issue, it could be so many things, and I hate PMICs. I deeply, deeply hate PMICs. It's from UC 300, okay. Bye-bye. No spam in my chat. Proceed. Tab 2. PS2. What's it called? P5VS2EN. P5VS2 EN. Anel, you're a scam. You're going to be scammed, Anel. Don't get me wrong. One day your number is gonna end up on a certain Reddit subreddit, and you're gonna suffer. Okay. By what is this guy again? U8100. What do they call this one? NordVPN, yes. We're just gonna call it PMU. PPBus 5VS2VIN. Source from PPBus. Goes through current sensing resistor. PPBus 5V. Man, I cannot remember stuff today. 5VS2 VIN. VIN voltage listed above is sourced from PPBus AON. Sourced from PPBus AON. done. So that's 5VS2. And the rest suck. And I don't want to do the rest right now. So I think I am going to call it quits. This page is pretty much done. We just need to go over PP3V3, UPC, and PP1V25. Both of those come from PMICs, and those are kind of hard. But I think this is good for right now. Again, most causes are going to be shorts, but this is a very good start, and this is well on our way to completing this. So we're going to keep going on this, and we're also going to do the 82238, and that's about it. So that's it for right now. I'm tired. It's almost 6 here, so I'm going to clean the shop up and lock up and get out of here. So thank you for watching, and I'll see you in the next stream. And if you are interested in buying some of that thermal paste, just go to our website, www.tcrscircuit.repair, and click the carbon black thermal interface material tab at the top. Current sale price is $29.99, and soon it will be available in other countries as well. So thank you for watching, and I hope the information here helps you at any time. If you want to see this information, it is repair.wiki/